Hey math friends, this is Precalc, section 6.2, day 1, part 2 notes. I wasn't paying attention to the time on the last one and I got cut off there. All right, so we were working on this example, solving a right triangle, but we noticed that this was a special triangle because it is a 30, 60, 90 triangle. So the first thing I'm going to do here is I'm going to draw another triangle as a reference. A 30, 60, 90 triangle as well. But we know that with our 30, 60, 90 triangle, we have those special side lengths. The side adjacent to the 60-degree side is 1. The side opposite, 60-degree angle is 1. The side opposite the 60-degree angle is the square root of 3, and the length of the hypotenuse is 2. So we can use that information to solve the given right triangle because basically the side lengths are just going to be multiples of the side length of our special triangle. If we look at the picture, side WQ in our triangle is the hypotenuse. Since the bottom of the triangle in the given picture is 13, and the bottom of the triangle in our special triangle is 1, that means that we are just multiplying all of our side lengths by a factor of 13. So we can just take the fact that if our hypotenuse is supposed to be 2, and we're multiplying by a factor of 13, that the length of our hypotenuse in this triangle should be 2 times 13, or 26. WH would be the other leg of the triangle. And since we know that the side length in our special triangle for that leg is square root of 3, we just have to multiply square root of 3 times 13, which would give us 13 square roots of 3 for side WH in our triangle. And of course, we already knew that the measure of angle Q had to be 60 degrees. So if we wanted to go ahead and fill these things in on our triangle, we could. This side is 26, and this side is 13 square roots of 3. Triangle solved. In our next example, this is obviously not a special triangle. I know this because the angle that's given in the picture is 46 degrees. So in this case, we are going to have to use SOHCAHTOA to solve this triangle. All right, well, let's figure out what we know here. We can certainly figure out the measure of angle A to start with because we know that if we have a 90-degree angle and we have a 46-degree angle, then angle A has to be 90 degrees minus 46 degrees, which is 44 degrees. Okay, so now that we know that, we can just do a little bit of SOHCAHTOA. If I want to start by finding side AG, I like to always use the given angle. So if I'm going to work with the 46-degree angle and I want to find side AG, triangle-wise, I'm going to call that side C because that's my hypotenuse, and I'm going to call this leg side B. That's just a little bit easier for me. So we know that the sine is going to be the side opposite over the hypotenuse. So in this triangle, the sine of 46 degrees is going to be equal to 15 over C. And if I do a little bit of fancy algebra here, multiply both sides by C, divide both sides by the sine of 46 degrees, I know that C should be equal to 15 divided by the sine of 46 degrees. Now you grab your calculator, make sure that you are in degree mode, and you're going to do 15 divided by the sine of 46 degrees, which gives us a hypotenuse length of 20.85. Remember, our hypotenuse should be our longest side, so now when we find that last side, MG, we just need to make sure that it is shorter than 20.85, so we have some confidence in our answer. So again, if I want to use the information that I'm given the 46-degree angle, I'm given the side opposite of the 46-degree angle. If I want to find the bottom of the triangle, that's the side adjacent, then I'm going to want to use tangent. So tangent of 46 degrees is going to be equal to 15 over b. And again, my fancy algebra tells me that b will then be equal to 15 divided by the tangent of 46 degrees. Grab your calculator, still in degree mode, and we find out that the length of the bottom of our triangle is 14.49, which does make sense for the given information. In the next example, we're given a picture of the triangle. This time we know our hypotenuse has a length of 235, and we are given an angle. This time it's in radians, right? And we know that that angle is pi over 8. Okay, well, we know that the two angles, the two non-right angles in our triangle have to add up to 180 degrees or pi. Okay, so we could use that information to figure out that the two non-right angles, the three angles in my triangle have to add up to 180 degrees or pi. So the two non-right angles would have to add up to 90 degrees or pi over 2. So the first thing I'm going to do is I'm going to find the measure of angle t. And I'm going to say that that's going to be equal to pi over 2 minus pi over 8, right? Or 90 degrees minus that, which when I find a common denominator is going to be 4 pi over 8 minus pi over 8, which tells me that my missing angle is 3 pi over 8. Okay. All right, so now that I have that information, I can go ahead and I can solve for the sides of my triangle. I'm going to start with, I'm going to call this side A and this side B. I'm going to start by finding side A, and I am going to use sine. I know that the sine of pi over 8 should be equal to side A divided by my hypotenuse, which is 235. This time, to solve for A, I'm just going to be multiplying both sides of my equation by 235 to get that out of the denominator. So side A is going to be equal to 235 times the sine of pi over 8. Since my angle is in radians, I need to make sure that my calculator is in radian mode. I multiplied 235 times the sine of pi divided by 8, and I end up with 89.93 for side A, which in my triangle is TH. Oh, and I'm sorry, I apologize. We are using SOHCAHTOA to solve this triangle. All right, one more thing to find, and that is the other leg. I've called it B, but in my picture it would be side HY. We are going to use cosine for that one. We know that the cosine of angle pi over 8 is going to be equal to side B divided by the hypotenuse, which is 235. So B is going to be equal to 235 times the cosine of pi over 8. Again, make sure your calculator is still in radian mode. 235 times the cosine of pi over 8 is going to give us a side length of 217.11. All right, we found all three sides and all three angles. Triangle solved. For our last example, okay, this one's a little bit different. We know we have a right triangle. We haven't been given any of the other angles. However, okay, since it's a right triangle, we can use the Pythagorean theorem to find our hypotenuse. We know that 6 squared plus 8 squared should be equal to c squared. Okay, that tells us that 36 plus 64 is equal to c squared. 100 is equal to c squared, which tells us that our hypotenuse should be equal to 10. If you remember from earlier in the notes, we know that this is one of our special triangles, right? A 6, 8, 10 is really a multiple of a 3, 4, 5, okay? So side TM here, we just found that's going to be equal to 10. But the problem is that since we don't have any of our angle measures, we can't use SOHCAHTOA, but we can use an inverse trig function. So for this one, we've already used the Pythagorean theorem to solve for our missing hypotenuse, but what I'm going to do is I am going to use inverse tangent to find one of our angles, okay? So I am going to say that the tangent of angle T, tangent is equal to opposite over adjacent. So the tangent of angle T is going to be equal to 8 over 6. So that means that angle T is going to be equal to the inverse tangent of 8 over 6. You want your calculator to be in degree mode. Inverse tangent of 8 over 6 gives us an angle measure of 53.13 degrees. And I can do the same thing to find angle M. I can say the tangent of angle M is going to be equal to opposite over adjacent, so 6 over 8. So that means that angle M is going to be equal to the inverse tangent of 6 over 8, which gives us an angle measure of 36.87 degrees. Could you have also subtracted from 180 to get that answer? Absolutely. All right, we found all three angles. We found all three sides. Triangle solved.